Fundamental of Computer Science 1 class. And so far we have covered up to chapter 5, and we're finishing chapter 5 this week, which is continuation of functions. Next week we're going to do file I/O, which is FS stream and IO stream and all that. The FS stream for the file stream is basically for both input stream and output stream. IF stream is for input file stream, and OF stream is for output file stream. But we will go in detail when we cover those chapters, including the file I/O. So tonight on week 10, I have some lab activity also for you guys that you could do. And the lab activity is also on here. So if you don't like the PDF because you cannot cut and paste the file to do the lab, I provided that one as a module also here. Let me show you quickly. So this is the actual PDF file that if you want to read it and then understand it, it's all in a nice format, readable in a PDF file. And this function that we did a week ago was the overloading concept of C++ with function overloading using one name, but passing different parameters or different data types to the functions as parameters. And we used the swap. Originally, we wrote it with two arguments. One was character data type, ch1 and ch2, and one was for integer data type. They both have the same function name, swap. But then I extended that one to have more data type being handled. Boolean data type, string data type, and double data type. And the reason we did this one is to show that, yeah, you can just have same name for overloading, but have different number of data types passed as argument for the same function. That's what function overloading means. And then when we are testing, running the program, so here the maximum number of lines 20. In this case, I wanted to clear the screen with end of line as many times as I wanted to do. Here, the function main is doing some variable declaration for different data types. Initially, for example, character 1 is set to L and character 2 is set to W. And X is equal 5, Y is 10. And Boolean 1, B1 is true, and Boolean 2 is false. Double 1 is D1 is 15.5, D2 is 25. And the string S1 is Wahidullah as my first name, and the string 2 as my last name, Lutfi. So what I wanted to do is all these different data that are happening within different variables, we want to just print them out before we do the swap function calls and after the function calls. So here, these statements are basically printing out within the main function what are their values for each one of them before the function is done, and then when the swap function, notice the swap function calls for character is passed with argument of ch1 and ch2, and then the prototype, when we declare them, we're using passing by reference because we want what is the data referred to or reference to. That data, when it is changed, we want that data. If we wanted to pass by value, we wouldn't get the swap value to work properly, because we want to see that as the data changes, we want to see that one. So and this ampersand that you put in front of the variable is like an alias, saying that ch1 is pointing to the same address that memory address that value changes, get that value. So there's this concept of address as well as reference. In most programming languages, if you're familiar with C or Java or another programming language, just when people use the reference, they're talking about memory address or pointers. But in C++, it's not that. Pointer is a different concept, or address is a different concept, and then reference is an alias. Reference is almost pointing to an address, and that you can say that, yeah, it gets an address, but in C++, when you're using a reference, you're basically using an alias, and that's what this variable is pointing to an alias. And if you're interested, I could show you these kind of concepts also with operating system, like Linux with symbolic link and inode structure and file system, that how pointers are pointing to different files with a pointer as a symbolic link, or as a hard link, how the two of the files have the same inode numbers as symbolic link in a different as hard link or something. When we can just see, when you're making hard link, you're just basically having two different physical file pointing to the same inode, but then you can delete one of them, the other one doesn't disappear. But if you on the symbolic link, you delete the physical file, the symbolic link is not pointing to anything, it's just an alias, which is meaningless. It doesn't physically exist. So a memory address on C++, when you're pointing character 1 to an address, that means that go to the address of where ch1 variable is defined. And whatever changes on the swap function that comes, it from that one, it carries on. If you pass it by value, you will not have the swap function. And we want to do the same thing with integer and then Boolean and everything here. You can see that these are the prototype of function declaration part of it. Then there's main, and then on main you are making function call like this, or like that for swap x, y, z, and then x, y, whatever the number of argument that is there for swap d, not x, y, z, because I don't have the z parameter. There's only two parameters, x and y. So you cannot just pass on a third parameters when it's not declared as so. And then on each of the section, when we do the steps, we're just using like a comparison of before the variable, what were there in the main when the swap is done, and after the swap, what is done. And then same thing with data type of Boolean, same thing with the string, same thing with character and integer. The only difference is that the values and the variables are different. And so when it comes to the function definition of it, then I'm doing exactly the same kind of work. Here I'm just clearing the screen, and then you could put inline or whatever, the number of lines that you want to just run the inline to clear it. This one, function swap for the character, as you notice that it is getting printed out the inside of the swap space, the function, what it is, and then outside of it on the main when it comes out, and after the swap. So I did all of this last night, and I just wanted to give it to you as an output, and then make one challenge for you. So one part of the code I modified. It's for you to detect that and correct it. So you're checking for a bug, and the reason, and this here's the compilation of this one. The reason, if you see all of this one is showing green, meaning that the swap, for example, before swapping characters, character 1 was pointing to L and character 2 was pointing to W. When inside the swap, this was still happening, but after the swap was done, the characters were swapped between character 1 and character 2. Now character 1 has W and then character 2 has L, and the vice versa, right? So the same thing with the integer, and notice that X and Y was 5 and 10, but then X become 10 and Y become 5 after the swap. However, on the Boolean, I did a kind of bug, induced a bug in the code that to work with you on the lab, make sure that when you're debugging your code, you can find out some of these kind of logical errors. Sometimes the syntax errors is that a typo, a semicolon missing, or some function names is incorrect. When you type in the name, you just mistyped it, or some variable was not initialized, you use it, or some variable was not declared, you used it, or something like that. But when it is not syntax errors, that is depending on logical syntax error, depending on the grammar of the programming language that you're using, in this case C++, then it might be logical error. Syntax errors are caught mostly at compile time. That's why it's also called a static error, that are at the time that you compile it, you will find it and you fix it. But there's errors that are called logical error, like something that has to do with the meaning, semantic of the program. That kind of errors is much harder than syntax error. It's not like a semicolon missing. You might have put a 2 equal sign where you need to put 1 equal sign, or you might have put a 2 instead of a 1, or B1 versus B2 when you meant one variable to be the on line 10, and then you instead use that variable on line 10, and instead of B1, you type in B2. So those kind of errors has to do with meaning. It will only catch up at the time of runtime. And then at runtime, logical error will show up. Like, for example, this function swapping, as at runtime, I detected that, oh, the swapping didn't happen after the swap function was called. So I marked it as red, say B1 is 0 and B2 is 0 also. Why this happened? It should have been one of them should have been 1, B2 should have been 1 after the swap, but it did not. So, and then these other ones like double, you can see that those ones happen. And the string also, the string had, one had Wahidullah, and then string 2 had Lutfi, and then substituted with the string 1 being Lutfi and the string 2 Wahidullah. So you could just see that how these ones happening. But then I wrote the same function and corrected and gave you an output saying that, okay, after the output, the Boolean should have an output like this. B1 is equal 0, B2 is equal 1. But on the program where I marked it here, B1 and red, this is a buggy code. So the source code above has a bug somewhere there. Your job is to run, compile it, run it, and when you see this B2 is equal 0, you need to go and correct, detect it and correct it. Error detection and error correction, basically find out the error where it is happening, at what stage. I'm not going to help you on the part of how you should detect it. You should get an idea, okay, it is on the function swap. And then after the swap variable parameter is passed, this one, somehow the data did not come. But then you start from there, you could see troubleshoot. And the technique that you use is, everybody has different techniques. And most of the techniques, somebody is going to find it in 10 seconds, somebody find it in 10 minutes or so on. Please make sure you get this source code, which I have it also in here for you. So I'm, this is the PDF version of it, and then so under the module section, you don't do this one right now, but when it is lab time, basically you go to this section where we have week 10. Under chapter 5, function for all subtasks, open this up. And when you see at the bottom of this, for this week, at the bottom, like every other functions, everything is there. At the bottom, I put the same kind of program with lab activity here. It starts right somewhere here. and I stated lab activity. So C++ function overloading demo is the title. This is what you want to just see, how C++ using one name like swap to overload multiple activities or multiple different data type, handles multiple data types. You know that we also did on the average, for example, to use multiple different parameters. So function overloading sometimes could take one argument, sometimes could take multiple arguments. That's also function overloading. In opposed to function operator overloading. Operator overloading when you're using like a plus symbol to do addition. When it comes to a string, you're doing concatenation of the two and the addition operator. So there's a lot of different ways on different classes you take that considers for example, function overloading or operator overloading. You will be experiencing multiple ways to write programs to do that one, especially with doing classes and struct and other arrays and vectors and other stuff. But in this class, you should know at least to this level, and then when it comes to arrays, I will cover some stuff, and when it comes to vector, I'll cover string and file IO. You will be well versed by the time you take your second course on C++ or maybe advanced course on C++. You already know some of the advanced features just at the introductory level. And then that is still a lot of information that for you to play around and ask question when you have question. So this is where you just start on the lab times C++ function overloading, and you are going to do that one. I'm going to discuss a little bit more on the chapter 5 from the area where we left off last time. Then when we come to the lab, you're going to start off right here, C++ function overloading, and then you will be doing that one. And I'll post it on chat also at the time what you're working on the lab part. So some of you that are coming a little bit late, and then you just make sure that you're there. And notice on here, I marked the one answer that was unread. So this is the part that you are going to detect. And then once it is corrected, it should have a value like this. Okay. Any question? Okay, let me see how many students are here. I'm still sharing my screen, right?
Yes.
Thank you. For some reason, I don't see that window. Let's see. Oh, yeah, it's right here. So on this one, the number of participants is 10. That's good. We're going to do a roll call sometimes before the break or right after the break to make sure that everybody gets credit for the ones that are here and the ones that are not here. They should not get credit for it. So Alec and Brendan, Christian, Freddie, Gabe, and Jason, Manuel, Sanchez, Simon, and Whitney. Okay. Any questions so far? No question. Okay, here you're seeing my Unix machine here. And then as you know that on this one, I had to install G++ version, right? The -- version would give you the version name. And then whatever version is 7.5 here is G++. So when you do the version and then you say which G++, this is the compiler. user ben and g++ dash dash version would give me the same thing, or just g++ dash dash version would give me the same thing. Why is that? If I just type in g++, without any user ben g++ where the binary is, it still finds it. The reason is because of this path. So user ben and user sben and /sben / user local ben, all of these, if it is in your path, on the $ path is my default path, automatically finds, I have it under user ben g++. So if I'm on any directory here, and any directory, I go to programs, and then I say which g++, it automatically knows that in the user ben directory, right here, user ben, on this one, there's a file called g++, and that is there, and that's symbolic link. You see that this is indication of symbolic link, meaning that there's another file that's called g++-7 for version 7, and that's linked to that one. So if I go to look at that file, say user, and the reason that you see this one as a symbolic link is because of this L. L means the first bit, if it is the first character, if it is L, this means it's a symbolic link. If it's a dash, it's a regular file. If it's a D, it's a directory. If it's a B, it's a block file. If it's a C, it's a character file. That's how Windows, or I'm sorry, Linux and Unix knows that this is what type of file is. This information, where it is from here to here, all of that information is stored into a structure in C or C++ called inode. The inode is the structure information node, which is basically showing that, okay, this is a symbolic link file by just looking at this one. And then it says, okay, the permission is read, write, execute by looking at these three characters. Read, write, execute by whom? By the owner, whoever is the owner here. This is the owner, this is the group. And then this 3 bits is read, write, execute, meaning that this is also read, write, execute by the group, in this case root. And this read, write, execute, because this is symbolic link, everything is read, write, execute, as well as like 777 in this case. So the permissions are set because anybody could run this command. It doesn't have to be root. And then I'm right now here, ID is wlutfi. My user ID is wlutfi. My group ID is also wlutfi, and then I belong to these groups. So I could just look at that file fine without being root. But then if I want to modify that file, if I want to delete that file or remove it, I cannot, because it is owned by the root. I cannot just go there, even though it says it's a symbolic link and I can just have the permission to do it, but it's actually user ben, the parent directory of that one is blocked. So in this case, if I just want to say, okay, I saw that one user ben, but then what is this g++-7, the one that is symlink, and that one is symlink to another file. And notice that this is also a -l, meaning that is symbolic link. So now let's trace that one, say, what is that one? x86 _64 -linux -gnu -g++-7. So that is the actual binary. And then notice that this is just a dash, meaning it's an ordinary file. But because the binary, I'm saying this is a binary because it's an executable file. If I just do a file on it, and this says that it is executable link format, 64-bit executable. So somebody who was a C programmer or C++ programmer at some point wrote the G++ and provided to us as a compiler. Now we're using that one to compile our code. So we better understand like some of the easy syntax like -- help to just give you help on everything on the command line. And we have been doing a lot of commands already to just create, for example, -o as an output file or -g to debug it and -c to compile it and so on. I mean, we temp save and everything else to save as create files that are save temp, actually not temp save, save temps to just create intermediate files, the assembly files, the object files, and so on. And then here, let's just go to C++ directory. And then I say, okay, that's the directory. And now I have my swap, the one that I was telling you earlier. Notice that for my swap, I have, if I just say my swap star.c++, and notice that I have two of them. One of them says my swap.space, and the other one is my swap underscore lab.space. The one with the lab has a bug in it. Notice this code and that code, the lines are only 47, 29. When you guys detect it, it should be like this program. I'm not going to show the difference now because otherwise you will have the answer for the lab. You may not work on the lab. I want you to work on the lab, try to figure it yourself. And that's when you learn things. When you see the challenge, you work on it, you see that one there. So if I do a cat -n on this one and say, okay, I'm going to just have this program there. Notice it's a lot of lines, right? 136 line. I could do 5 more to stop one page at a time. And then you could see this. Next week, when we do the file IO, I'm going to show you how to write some of these operating system commands like cat or more or type or Windows or clear the screen. You can do it with C programming easily or Python easily yourself. You could write similar code. It's not hard. And we will show you that. And then you will learn it and you will practice it on your site. Like on the command line, some of the other things that we showed you already. And then there's something with your main program that I will also discuss this Wednesday, and the main project. The main project, we will do that. So for a minute, I'm going to shift gear from the MySwap to the main project and show you a couple of things that I'm doing here. On the main project, I call it my calc.c++. Remember, I was telling you that you're going to write a calculator that has at least 10 different functionality, addition, subtraction, function that performs addition, subtraction, modules, multiplication, division, arctangent, and maybe square root, power, and so on. All of those ones average, and I wrote this helper for you, and then you're going to start off with this helper. Last week, I believe we had another example. We did this calc.c++ for calculator. This file was very quick without writing any functions. And I only did a function with adding 2 functions, right? So 2 variables, and we did it, and the function was here, was doing that one, and then it was returning by values. But then I said, well, this is too basic. You're already past chapter 4, and you already passed chapter 5, and now by the time you finish the project, you're gonna do a different one. So I wrote this one for you last night, C++ for the project, and then cat -n my calc.c++. So on this one, let me just do a 5 more actually. So on this one, you have a kind of like common section. On the common section, I wrote like what is these 10 functions that you will be doing it. So addition, multiplication, division, subtraction, these 4 of them are already done for you. The function I wrote it, now if you have to do the module, maybe you could just see the way I did addition, you just change the operator for module and then do the same thing with addition or the multiplication, similar module will be done similar. For the power function, for example, here I'm saying where x is between 1 and 10. So you're returning power of 2 to the power of 1 to the power of 2 to the power of 3 up to the power of 10, which is 1024. So that would get you into a for loop. You're just using a for loop to just generate all the numbers. Very simple function. But writing this simple function is teaching you modularization. When you write module programming, you're going to learn saying, well, I could break a big program, top-down design program. We always teach you saying that break the program, the bigger problem into subtask and break the subtask to smaller subtask and then write that subtask as a function, which would be an algorithm or something that you're going to have some formula to calculate and return something or not returning anything because you're having a void functions, but you're just finishing that task. So when you're doing this kind of routine, the entire things, all of a sudden, your calculator have 10 different functionality. So they can get an arcsign of some variable x. In this case, x is 0.5 and pi is 3.14159.265 default number. And then average, for example, we talk about getting average of x and y for 2 numbers, but what if the average is passed with 3 arguments? So can you get it? Yes, because you're doing command line reading from the command lines, argv sub 1 would be pointing to the first argument, argv sub 2 is pointing to the second, argv sub 3 would be pointing the third one, argv sub 0 is pointing to the main program, and then argv sub n will be pointing to the n argument. So that way you can always do average of 10 numbers or average of 100 numbers by going to a for statement and just get the arguments, pass it in and convert it. Obviously the argv sub 1 is coming with a string character. This one is character pointers of strings, right? So argv is a string of, but it is character pointer to an array of strings. So argv sub 1 is 1, and the first element is argv sub 0, the second one is argv sub 1, and so on, of the element. Now you're getting that data as a character string, then you have to convert it to alpha to integer. Alpha to integer function calls, now you're changing it to long int, and then this variable that you say long int 1 is pointing to number 1, long int 2 pointing to number 2. And I'll go through this one a little bit more detail on Wednesday, and then I'll release this one sometime either this coming Wednesday or Monday. That way you can start coding for your project whenever you have time. But having this options by Wednesday, it could give you a head start, and you might finish it in 1 day or half a day or maybe 1 hour to do all of them. You could just depend on how much you have learned in this class and how much you have read the book and how much you're following my videos on the lectures and everything. And so some of them is pretty honest answer is just as always in the lecture, or it is always in the material that I cover. So a lot of them are already there. And I'm going to just show you, for example, look at the function that is already there, how simple it is. So when you write the module, you write the same kind of name. Instead of this operator, you just use the module operator. But the one that are on the top here, like for example, when we say is power of 2 to the power of x, then I did not say that where x is the argument sub 0 or argument sub argv sub 1 or 2 or something. So in this case, it is a for statement that x is between 1 and 10. So within your program, in a function, you're doing this one. The void function that it's doing this one, it just basically print it. It does not return the value, but the printout is printed within a void function. And then the same thing with the square root is here is the argument v sub 1 is there, or you could try another number inside your code. But these options are here for you to improve upon. So you write 10 functions, and if I ask you to write 20, or maybe another class, you're doing it with GUI interface, so you have an interface with calculator that somebody could push buttons on a web interface, then obviously this can be extended. But that's why you're writing in modules and functions. That way you can extend it easily. And scalability of the code is when the code is accessible, and then code is much easier to modify, because you don't have to kind of like rewrite the whole thing. It's code reusable. Reusability is there. You say, oh, I wrote this addition function, now I'm doing multiplication. What is changing? So I can do some of that function and change those areas that I do in passing arguments. So there's a lot of technique that you will do over time. You will learn a lot of steps, and you see the difference and the advantages on those ones. Any question on this? Okay, so if there's no question, let me show you the other one, my swap underscore lab.c++. This file, if I just show you the source code, which is also on the module on the chapter 5 earlier that I showed you, and also on the PowerPoint, since it's on the canvas on the module for chapter 5, open that one at lab times, copy the entire thing, and then once you get it, then you need to do this and run g++ -o for output. Let me make this screen a little bit better. So I wrote something called my xterm.sh. This is a Windows, my xterm.sh. And so basically I'm using xterm commands to just create some 3 nice different X Windows session. But for that one, I need a terminal emulator. So Xming is a free downloadable that way I can emulate my X session through from this machine to my other machine, which is this one. My remote machine is this one, which is a Linux machine, uname -a. And then if I say, who am I? Who am I? It will tell you that I'm coming from this 192.164.254 there. And this machine IP address of this one, fconfig -a, this one is .10. So I'm on the .10, but I want to just use the terminal, the X session of this. That's why I did that Xming. Now, if I do that one, Xming on the open source thing, I could do echo $term is my terminals that, and then if I say echo $display in uppercase, then it said do that display. That means I can run an xterm command here, and it opens up an xterm file with that white default window. But I don't need that white default window. I need to just use a different setting, so it's much easier for my eyes to read it. Let's see if it opens it up now. Yeah, it opened it up here. So this is the default window, but that's too hard for you to see it, too hard for myself. So I'm going to do this, and that I run this .my xterm, dereference, it opens up 3 windows, one blue color, dark blue, one dark green, and one dark red. So those 3 windows, and let's say just see this one is blue, that one blue, and then I think that dark green might look okay, because this other background is also green, and it is easier to just look at it here. Should I go with that one or blue? Your choice. You just let me know what is more easily readable for you, or this. In fact, let me just try one more thing, see how white one looks. So I'm going to do a vi my extern.sh, and I'm just gonna copy one of these ones, y paste it here, and then I'm gonna change the background to white. Let's just do it white completely, and then I'm going to make the text in black. Black on white, and that's what I'm going to make those 2 color match, so it's easier to read it. And then if that is more readable, we will use that one. This is the one, that color. Let's see, PWD and this. The problem with this one, when you're opening out like my swap underscore lab.c++, some of the, it's still readable, but not as readable as the other one. Let me go to the green one, or let's go to a blue one. See if, how blue one works. Blue might be better because of the fonts. Yeah, it looks readable more. So vi my swap underscore lab.c++. Yeah, this is much more readable, I think it is, and the font and foreground and background. Some of these things, like if you go to the top, you can see that it is more easily distinguished in terms of the characters. So is that better in terms of your eyes too, or just for me?
Yes.
Okay, thank you so much for confirming. So this program, my swap function that we did, we basically wrote it, and then now let's just save it, and then we are going to compile it. So I'm going to say G++ -O for creating the output called my swap underscore lab. And then the name of the source code that we want to use is my swap underscore lab.c++. So in this case, is saying no such file or directory. My swap underscore not lab underscore lab. Sorry. So we created that file called my swap underscore lab. As you can see, my swap, and then you can see that there's one file here. This other file was the one that I created last night to send it to you on the stuff. So I captured everything in that file and then do that here. So now I'm going to run that my swap. So if I want to run that executable, now let me just do clear screen. First thing, let me ask you a couple of questions before I do it. I just did one part of it. So this is my file called my swap.c++. Everybody sees it. Now, if I want to compile this one using G++, what is my second option here? Minus?
O.
O, thank you. And then the reason I'm putting is dash O is meaning what?
Output.
Yeah, it creates an output, and that's dash O. I gave it an argument. That means that if I say dash O, the G++ knows that, okay, in addition for me to compile it, I'm also linking it. And then as I link it, I'm going to create an executable file called my swap underscore lab. So my swap underscore lab is the source code. It says that generate this executable file from this source code. And then if this source code has syntax error, it will just fail and it will not do it. But if it does not have any syntax error, after this I press enter. Oh, I did again lib because I work a lot at the libraries and I'm keep typing lib. So, okay, so now echo $? Meaning it went successful. There was no syntax. It did create a file called my swap underscore lab. And then the other file is .c++. So my swap underscore lab.c++. Those two files are there. What is this? What type of file this one is? .c++. If I look at that file and I'm on Linux or Unix, and somebody says, can you tell me which one of this one is executable, which one is not? How would you answer that question? So on Windows, thank you. On Windows, what you could do is you could find by the file type, like .c++, CPP is the source code. .exec is the executable. .o is object file. On Linux is similar, but on Linux you don't have to have .exec for extension. The reason that on both Windows and Linux, you could have any file name by any name, and still, as long as they are executable, then you could just call them Wahid and it still will execute because of the file type. On the header information of a file, it says, okay, this is a text file, this is a C source code, this is a PDF file, this is an executable file. So there's a command on Unix or Linux, it says basically, just if I put file in front of this, and instead of ls minus l to list them, so if I say file this, it tells me exactly that they are executable and there's source code. So if I just do this one, only show the executable here, I could do file on that file name. It just says that, okay, that is executable link format. And then notice that file is already, the permission is set to X for executable. These other ones, they don't have an executable permission set because they're source code .c++. So if I read the file on C++, because readable, writable, then I should have read, write, execute. I don't have a permission. I cannot say my swap underscore lab.c++ and say, oh, this one gets executed. It says that the permission denied because that permission is not set. Even if I change that one, say change mode 755, and then that file, and let's say for now, I'm going to change it so I could show you my swap underscore lab.c++. Even though I did it, at this time, if I just say this ls minus l, notice that it is set to executable for both of them. But if I just want to run that code again, it's going to say, well, that is not, is a directory, line 1 is this. So it tries to execute something, but it did not find it. It's reading some comments, it's source code, okay? So I'm going to change the permission back to change mode. And the permission originally was 644. So I'm going to do 644, and then my swap underscore lab dot C++. Now, if I look at my swap underscore lab dot C++, the permission is read writable by owner and everybody else's permission. If I want to just make this one also the group writable, then I could just say 6 there. And then I could use other syntax of plus U for user, plus G for groups, and then dash U dash G, and then so you set up certain permission. But this is an octet number, easily you could change it. So now I made it read write by owner and by groups, and that's a source code. Again, my swap underscore lab dot C++ and my swap underscore lab itself. One of them is executable, the other one is a source code ASCII text. You can see the source code. So now if I want to my swap underscore lab, if I want to just see these three files, if I do a file, what should I get for this text file, .text file? What type of file is that? Based on the extension, you can tell it's a text file, right? It's a text file, and then you can see that it just says ASCII text. And because it has some C++ source code also, it just distinguishes it from other text files. If I just say echo, this is a test, and then write it to a file called test.text. Now I just created that test.text, test.text. And then if I just say file test.text, that is an ASCII text. It does not say a C++ because it does not have any line of C++ code. But if I say, now let's say, just say this, in addition, I just put one include directive here, say pound include IO stream. Let's say I do that one and override that file with that information. I could append it and do it the same thing, but let's just look at the file now. Now it says a C source code. Before it was just saying ASCII character. It sees that one, even though I have IO stream, it identified as C source code. If I just rename this one and say move test.text as test.c++, and now I say file test.c++, you can see that it says C source code still. But let's just add one more line to it. Let's say echo using namespace std, and then we double greater sign to append to it, append to that file. Now the test.c++ has 2 lines, and so the semicolon is missing on the second one, and then we could add to that one. But let's just do this, file test.c++, and then it still says that one. I'm going to just put, you could even do a substitute here with the test. So you could do set minus e substitute the word substitute like std to std semicolon, and then globally, and then test.c++, and we just write it test1.c++. Let's see, the test1.c++ has that semicolon. So if I do a difference between test.c++ and test1.c++, we just modified one line. And now if we say file test star, you can see that test1, because of that semicolon, it just recognizes it as, oh, some information in the file is saying that that's a C++ rather than a C, which, and the system is mistakenly identify the second file as a C source code, not a C++, because a semicolon is missing. So it is not just like, oh, that is smart enough to know that, oh, I'm not doing a printf statement, I'm using a using namespace, which is not part of the C. It should have identified, but because I modified one line to say this. So if I go say test.c++ here, and then I just change that std to have a std here, and even I don't write anything afterward, I say now do a file on both of them. Where's the file? So if I just type in file test star, both of them are saying C++ because the syntax is so much alike with std semicolon. But again, the other one was actually C++, and the system mistakenly identified as C. So the fact that these programmers are writing program is not like those ones are bulletproof kind of things. That's why we have different version of these systems. Sometimes different things have different bugs, and you have to code it. I'm going to show you different ways to detect bugs, and then how we correct it, and how we kind of put exception or try exception handle rather than assert something that is going to assert certain condition that when it happens, your system might break, and you just want to test that one in order to prevent that your bug from happening on the production when you deploy it on the production. So part of chapter 5 was the assert, and the topic that we kind of jumped a little bit ahead of us last week, and we covered it a little bit, but I want to just show you an example as well on that one. So let me see, 5.4, and the stub and drivers, we talked about that one last time. Where was the assert? Passing by value, passing by parameters, we discussed that one. So let's go down slowly here. If your eyes catch that word assert somewhere here, tell me that it's right there. Assert or assert. Assert is the library that you include, and the assert is the function name. When you're writing it inside the function name, you're putting some Boolean expression. And I give you the example, for example, division modules that if divide by 0 is not allowed in your system, you want to do assert. See how to initialize instead of this wrong, and initialize variable. The factorial, we did that one as well. And right here, so right here we say the assert macro, right? So the library name is CAssert for C library assert. And then you're just going to use the function assert with some Boolean expression. And the Boolean expression in this case is if you're dividing like a divide by two numbers, and then the result is there. Let's write this function quickly, and then just look at the assert, see how our program behaves. Basically, your program, when you do the assert, if you're checking for that bug. That bug happened, your program is gonna fail, and you're going to just assert certain things, and if that data is entered by the user, your program is going to fail. So in order to prevent it, you just do this debugging with assert statement. And once you do the assert statement, you say, okay, I found that that's a bug, I'm going to correct it. So let's write that one here. And let's reuse this one. So right here, I'm going to do call it. Let's say if I have a function already, assert something. Yeah, it's already there. So I could just we did it on October 20. So I'm going to just open it up. Assert dot. Sorry, I mistyped it. vi assert.c++. So this is the program, and I'm going to make it a little bit bigger. Okay, it's a small program. Set in U. It's only, I believe, 39 lines. So if we look at this one, we're using the IO stream and we're using the CAssert library. So if we are doing those ones, our job is to do get input and then show result and then divide a number. And notice that some of the information here, we're just doing a function by reading two numbers, number 1 and number 2, called get input. And then both inputs are double. So we're getting that one and returning a result of double. The divide is just doing the same thing, get 2 input and then returning a double as a result. In the show result and double, we could even return it as void and then print it out on that statement. We could do that one. But if we want to print return a result as a result, and then we must return a double as a result. So that value could be done. Here in the main, when we are creating the two input variables, one is number 1, the other one is number 2, and the result is to do the calculation afterward. So we're making 3 function calls. In this case, the get input function calls is within the main, it's getting the data from the user for number 1 as a double and number 2 as double. And then the assert is that denominator number 2 should not be equal 0. So once we put this assert, if the user gave the input as 0, then our program bomb out. It's going to fail. It has a bug. And that is going to tell us at the development area that, oh, my program is failing. So then I will have to do some kind of modification. Instead of putting this assert, the assert statement, you don't put it on your production environment. You just do some kind of try and exception on if that value is equal 0, you return a meaningful program output rather than just failing segmentation fault or a core down file or something. That's a bug and that was not caught or was not tested. And then assert is going to help you to test these kind of bugs. And one of them in this case is for division function. You do denominator cannot be equal 0. And so you cannot divide by 0. That's what division by 0 is not allowed. So instead of doing assert, you have to do a echo or see out the statement, say division by 0 is not allowed. And then your program still gave a meaningful result when the user input a wrong value. Show result, and I mean, obviously, the get input, you can do multiple ways of saying that if the data was entered was incorrect and it was not the right data type. But here, maybe I'm not checking for those ones. As you can see, it's not doing that one, like the cn dot ignore, the cn dot clear. We're not doing any of that one. So if I look at back here on the divide and return is just once it is called, if the assertion doesn't fail, it's going to do the result, and then the result is going to come as a result of this function divide, and then show the result is basically, since the divide number is returning number 1 and number 2, and value is stored. This is a function call to divide when the output is actually returned based on this return statement here, whatever is the value returned here is going to store it to this result double variable. So the result double now is passed on to this show result, and then the show result is just basically says, oh, and then it's there. So here we don't even need to do this one as double. We can test it to see with void it should work the same way. But I'm going to just compile it first with everything. So if I want to compile this source file called assert.c++, can a few students get participated on this one, and each one of you tell me the syntax of one of them. So my first question is, how would I just compile this one and generate an executable called assert? What is the compiler command that I would use? Can somebody please speak up?
I'll give it a shot. G++.
Okay. Thank you.
-o.
Okay.
Assert.
Assert.
And then assert.cpp.
Thank you, Gabe. Okay, so this is very good, Gabe. Thank you. Since it did not have any error, it just compiled, and that's successfully. So now the second question, anybody could volunteer for this question, is if I do ls minus l and d, and then ls minus ld meaning should just list me the name of the files, long listing of the files and directories, assert and assert.c++. What should I see as output? One file, two file? So the output of this one is a list, meaning give me a listing of this file and this file. Minus L meaning long listing. Long listing is like this format. This from here through here is all the details, minus L. D is just, if this was a directory, it does not read the contents of the directory. It just lists the first name of the file that find it. And so if I had another directory called assert, XYZ, then I could not just get it because this is specific to these two file names. So now these are there. Why is one green and the other one is white, and then white, one of them has these permissions, and then one of them doesn't have these permissions? Can somebody speak for me, please? So that whenever Linux identify the file that is green, here it says, oh, this one is executable. So I'm going to mark it with the color green, so it distinguishes from this source code that is just text file. And then this file that has read-write ownership and read-write, that means the owner can read and write, the group could read and write, other people could only read it from it. But then when it has read-write execute, meaning that this is a binary executable, so that means anybody could execute it, because the executable bit right here, X is for owner, for group, and for other people, or all set. So now if I want to run this executable, what is the command I'm typing on Linux?
/assert.
Thank you so much. So why would I type / in this case?
Isn't it a bash command?
Yeah, so on Linux and Unix, everything is /. The directory structure, the command that you do, the path is showing as /. And Windows, so if I go here on the Windows and then I say, look at the slashes. The slashes on Windows is backward, backslash, right? And then if I just do like a directory here, the files that are there, let's say I go to sources. Once I go to that one is sources here. And then if I just have an executable file, They're not here. Let's say just some files. There slash c:/ users. Actually, I could go to this other directory, pasadena.edu. Store 21. And then right here, and under the sources, CD2 Visual Studio sources. So right here, I'm going to see what is the names Visual Studio dash sources. So this one, I have some executable. If I want to run this we.exec, then I'm going to do a /we.exec. That way, just I get the output of this one. If I say ./we, I'm not on Linux or Unix, it would not recognize it. So because on Windows, the directory is /, you're going to always type in a /. And even if you look at the percentage path here, percentage path, you see all that /. And then here, if I just look at the echo directory of $path, all the directories are /. And if I go to the root, for example, here, if I say go to the root, and the root is this. So root/home/wlutfi is my home directory. If I just type in /home, it's not going to find it. It says no such file directory. So Gabe, you were right. Thank you so much for giving that name assert. So what you're doing is, like Gabe said, is ./assert to just execute it. Now it's going to ask me for some input in there. So let's type in 20 divided by 10. And it says the result is 2. We're going to run the same program again, and then we're going to say 50 divided by 5. And then it's 10. So far, so good. 10 divided by, let's say, 3. So it is accurate because we are getting the floating point number since we did the division by define it as double, not as integer. If we were doing as 10 divided by 3 as integer, we would only get 3, not the point value for it. And so let's just go here and now do assert, and then give a value for 10 divided by 0. Now notice that the assert happened. It says assert C++ line 18 and main, assert number 2 divided by 0 was not allowed. It says that failed. So it created a core dump of the file. That's kind of embarrassing if somebody as your customer look at your code, say, well, I ran the program and I gave the input 0 as denominator. I didn't know that you don't allow divide by 0. I'm not a mathematician. I just novice, person. I just do not know that kind of things. Can you just please inform me that, okay, divide by 0 is not allowed rather than do this, right? So every time you just run the assert and you give a number and then say 0, then your program is going to fail. And it says abort core dump. Sometimes there's a file called core, but because I don't have the permissions, maybe on the root with running as this, the core files or the /root on /core files, wherever supposed to create that file, it did not create it. If I just do ls minus ltr and then say, okay, this is my binary, where's that core files that says core got created. Now let's do the same program. I'm going to do sudo su dash and then become with higher privilege, and then now run assert, see if the core files gets created on this directory or still not going to create it. And we say assert, and we say 5 and then divide by 0, and then says the same thing, core dump minus L core nothing star core nothing find slash minus name core minus type F. So this one is searching for the core to see if any files there. This is not the core file that I'm looking, because this is from a snap from the Linux things, initial RAM disk tools. So anyway, I'm not interested even if that file is there at some point. I'll just delete that file. I'm going to Control-C out of it. So let's fix the part where we supposed to fix on the assert.c++. So vi assert.c++. Can somebody help me with the syntax of correcting that one? So right here, we did an assert here. So instead of this assert, we know that this is not good. We're not gonna even have this module used, okay? But if we don't do that one and then we still do divide by 0, let's see what happened here. We're going to just did not even know about that kind of bug. So we say G++ minus O assert, and then we say assert.c++. And then run the assert. In this case, I'm going to say 10 divided by 0. And right there, it says the result is infinity. So the program did not fail, but it did not give a correct value either, right? So if I just run the same thing, what if I just put an A on the character? Notice that the value was not even handled, this one, because we did not write anything for this. So now we say, okay, we found out 2 bugs in the code. One is that if the division by 0 is not allowed, the other one, if we put the incorrect characters, the program just return a result of 0, meaning that, oh, I did not even give a number 2, you already failed. So if I type B, it's already failed. If I type C, it already fails, right? So now let's go fix the program, assert.c++. So I fixed the first part by commenting out, the easy part. Now the hard part, can somebody give me a very easy idea that this is like so simple, that if I'm asserting this one, number 2, what should I write here to check some kind of branching, an if statement? What should I write? If some condition, then do something, else, then you could say cout divide by 0 is not allowed, right? So I give you the entire things here as how you skip it, but I need to have this condition. So the condition is already here, right? So you know that that condition made your program fail. If that condition is if number 2 is not equal 0, then you carry on this division, right? If since I comment this line out, that's basically not gonna ignore that one. The compilers ignore it. If the number 2 is not equal 0, then what we are going to do? We're going to basically do the function call or divide and return it as a result. Otherwise, it's going to just say divide by 0 is not allowed. So this if statement else can just prevent that one. Let's see if that works. So we compile it again with this G++ code. We run it again with this assert. This time we give again 10 divided by 0. And we just see divide by 0 is not allowed. So our program succeeded by returning a $sign question mark as a 0, meaning successfully ended. So if I run this program 100 times and I give different numbers, divide by 0, it's always going to say divide by 0 is not allowed. So that part is already done. The next part is that we need to do the same thing with not allowing the input values, right? So let me put a statement here, it's a dot here. And then since we're doing an inline, that's okay. There. The show result is also having the inline. So I'm going to do another thing here. Instead of doing this one double, I'm gonna do the show result as void. Because I don't think that we needed to say this one there, because the result is already here, passed on, and then it's going to print it out. And so we don't need to define that one. Let me just compile it here, C++. And then, oh, the reason nobody caught me making that mistake. You know why that gave us as an error here? Show result and show result here. Anybody? Like here, I just change it to void. This is the definition. I need to do the same thing on the declaration. Here, void. You cannot declare it one way and define it another way. So this is the prototype. That's why it's called prototype. Whatever the format that you do here, without the semicolon, you write it with the definition. So now we're running it and compiles. Fine. So we're going to run it with the executable file, and we say, let's say 100 divided by 5. It's 20, that's correct. 100 divided by 20, 5. Oh, I did the same number twice. 100 divided by 10. Okay, so we do get the value correct, and if I just put it 10 divided by 0, obviously it says division by 0 is not allowed. So when you do regression testing, you want to make sure that whenever you make one change, other functionality does not break. That's why you are going to do regression testing, testing after testing with the same kind of value that previously you checked the functionality. So the part that is still fails is the characters, that A and B. But the void, as you can see in this case, is returning correct values when you're saying the show value is just printing it out. It's not doing a return result. That's why you didn't need to define that one as void. So please notice that one, assert.c++. Here, this function, right here, this one was defined as double. That was a mistake. It should have not been defined as double, because you didn't need to define it as double when you're not returning anything. When you're not returning, you should define it as, these other ones were returning those double values, so that's why. And then whenever you do it at the prototype, you also do it at the definition. See, this is the definition. You're defining it from this brace to this brace. That function is defined here. So we did that one. Let's just go via my swap.c++, and we are going to just, no, not my swap. Sorry, clear screen. VI, what was the name of this one? Was assert. Assert.c++. I saw a different kind of like line numbers and everything, so I said maybe something is there. So if I just look at this code and then say, okay, what is the problem with the CN? So I'm reading some CN. Where do I read the input? So let's just look at the CN statement. So right here on the get input, the CN is all there. I'm reading a CN of, let me put line number, set NU. And notice that at line 37, I'm reading a C input number 1, and at line 39, I'm reading another number, C number 2. At this time, I'm not doing any checking on it, right? I'm not checking any numbers, and then I should just do some validation for the CN to make sure that if it is not right, I should just keep reading the input. So let's just do that statement here, and then we just say if we're going to check if not cn.good, meaning that we were expecting to double, and the cn.input did not return double. It did return some character, some kind of other string or something. So then what we should do here? Then we should just say, okay, if that's the case, let's do cn dot clear. We're going to clear that things, and then cn dot ignore. And ignore what? I'm going to do up to max underscore max, actually int 8 max underscore max. That's the constant or integer constant max. And then I'm going to do up to new line. And notice the new line syntax is the backward slash. Similar, whenever you skip it, is also backslash. So new line slash n slash t slash e, I mean a for alarm and other things, all of them are backslash n. For new line, backslash t for tab. So right here, I'm doing that one. Then I'm going to do cn.sync because I want to sync and data. Now I'm going to do another cn and then read data back, say number 1. Okay, so this is for number 1. We are going to do the same thing for number 2. We could also, instead of using it like 2 values, we could do like two statement here, say number, and then here when we are just doing the cn, we could do that one, say enter 2 values. Otherwise, we have to write 2 different sections for different ones, and we could do that one if we want to do that. If you feel like you want to do one at a time, it's easier for you like that. That's okay. If you want to do a multiple of them, I would rather suggest that you should do it one at a time because you don't want to get confused with one of them, maybe the user inputs, and then the second one input wrong, and then it's still the data is coming. But now here is the thing that since both data has to be entered as you expect, otherwise you don't do it, it is going to work on either case if you just write the if statement one at a time section, because whichever one it doesn't do it, you just keep looping it. So instead of doing a if statement, you're going to do a while statement. While the data is not good, just read it. But because I'm doing one section at a time, I'm going to do a semicolon here and get rid of this line. And then here, I'm going to finish the while statement. And then right here where we say while this, and then we're going to start a, we're going to start a block for the while statement. So let me move it here. I'm going to move it here, and then this other one, I'm going to move it here. So now we did it for this number 1. We're going to just change this one to number 2 for the second one. I will tell you why I changed it to number 2. Because it's much easier for me to leave this one here. And then line 40 is through line 46. That's 6 numbers. So I'm going to say escape 6YY. I'm going to paste it here. So I copied the 6 lines from there. Actually, I missed one. This, I'm going to add that one. I should have done 7 lines. So see out. And then whenever the user gave the incorrect value, this one is not good, it's going to come. But before it does this, it's gonna just clear it. You wanna just give an input here too, again, within this for statement. Making sure that while we are clearing it, this line does not matter the cout where you put it here or you put it just before this line. But for functionality, kind of readability, you want to put it at that point. So right here, this one for number 1, you're going to copy this one line and then put it here too. So in case if the user made a typo, they're going to just get a prompt on this. While the user does not give input, we keep reading it until they give a good double for number 1 and number 2. So this part should handle that function. Now let's do this and say, what is the command again? Another person beside Gabe.
Professor, you didn't change the variable for the first while loop.
Thank you. So let me check that one. Vi assert.c++. The first variable. Okay, yeah, right here, the number 1 that we want to read is good catch. So number 1, the CN, when you're reading it, you want to make sure that they enter number 1 and then number 2 is there. Whenever you cut and paste or copy certain lines, be extra careful. Sometimes I've done it so much and I just know that, okay, I can catch it afterward, but that is a typo. That typo or much, much harder because they give you a different logical error that's much harder to just catch it at runtime. Because if you're reading number 1 and then the values are stored in the variable number 2, now you just got a number 1 with null. And now later on you just say, I'm using null number 1, I just gave it the input, but it is not running it. So coming back to my question as on the assert, if I want to compile this one, anybody but Gabe, could you just tell me the syntax of compiling this code so I'm going to rm this file assert, and then now I have only assert.c++. So if I want to just compile it, this one, to generate this file executable, and I'm using the G++ compiler, can somebody give me the full command? You all did it on your midterm. Hello? It cannot be that everybody is just watching TV or working on something. You guys gotta pay attention to the class, please. Otherwise, thank you. Go ahead, Whitney.
No. So assert.c++. Oh, first you do G++, then assert.cpp.
Assert.cpp.
-o.
-o.
Assert.
Thank you. So you can see, who was this?
Ruth.
Ruth. Ruth used a different format of putting the source code first and then the output file later. That is still the G++ compiler is smart enough, saying that, oh, argv sub 0 in this case is the source, and argv sub 1, I'm sorry, argv sub 1 in this case, argv sub 0 in this case is the program. argvsub1 is the name of the source code, and argvsub2 is the option, and argvsub3 is the name of the source executable. So that would also work, but there was a typo on the syntax, and this time it just generates some syntax error. So it says, and function double, get input double, double, and then says 39.9, expected right brace, but before this one, it missed that one. And then saying again on line 49. So let's go on to line 39 and 49 and see why we're missing a right parenthesis. Okay, so this is the name of the file. The line 39, if I go escape, and then shift colon and type in 39, automatically Vim is going to take me to line 39. So right here on the assert, you can see that I used 3 left parentheses, but I closed it with 2 of them. So this one closed this one, but I did not close the last one. I needed one more right parentheses for this last one. And as you know that the editorial identified that this one is for that, this one is for that, and this one is for that. So on line 49, I had made same mistakes. Right here on that one, I just forgot one more right parentheses. And now it's going to be okay. So now we're just going to run the same syntax that Ruth gave us. We're going to just run it and it's going to execute. Notice that it did it exactly like what we did. So I'm going to do assert.c++. I'm sorry, assert as executable. And we gave the number 10 and 5 as should do. And then gave a number. I'm going to say A. It says, give me another correct value. I say B, it says, give a correct value for number 1. C, as long as I do it, it does not work. So I go uppercase W, it is still not. Now I give a 10, it says, okay, give me number 2. Number 2, I'm going to do A or D or C, whatever, Z, whatever. It's not going to say, keep prompting me for number 2. Now I say number 2 is also 10, the result should return a 1. And then that works. Okay, let's try it one more time. Assert. And this time, give me an input. Somebody just say any input. Character, number, double, whatever. Just give me some number that you like me to test. And why am I asking you guys for an input when I can just enter it?
Can we do number 4, Professor?
Sure. Every time you just are doing some coding, you don't want to be the only tester because somebody is going to give you different numbers and that you never tested. And that way, maybe you catch the error that you had not noticed it with one person running the test. And most companies, they have quality assurance departments that they do QA testing for everything. Whenever you are releasing something in production, you have to do enough testing. So what should I give you the second number? What number? Or what should be the input number 2? Anybody?
Number 8.
8, okay. So it should be 0.5 and it is accurate, right? So that is good. And that this assert program now works with the way we want to do it, assert.c++. So I'm going to also post this one in a section where it says assert and then possible outputs also. So can somebody help me if I just want to debug this one a little bit more? And then I want to use the G++ compiler and the module debugger with GNU debugger. So can somebody just walk me through the steps, or I need to show you guys myself? Anybody knows those ones that I did last times? No volunteer? Okay, let's do it together. I'm going to just ask question and I'm going to compile it. So right now, if I just have this file called assert, that, I'm sorry, what happened here? Okay, somehow the window closed on me. So I'm going to just use this other one, that's fine. We could, actually not this command line. So let's just use this black window because I was not active on this one. You can see this one says disconnected. So when this one disconnected, the calling program that I invoked this one as a subshell, it just died with it all of a sudden. So in order for you to not experience that issue, sometimes you can do this. So let me just go to terminal here and just open another one. On Linux and Unix, you have this mechanism called that screening or a no hub process, that you have no hang up process there. So if I just do PS here, echo $shell, my shell is already bash, right? So PS bash is my shell, echo $$ is just 747, meaning that this is the default shell. So if I just run another shell, like say C shell, now my shell I changed to a C shell, and then I say PS here. Now notice the C shell is 761, the process ID. So now if I say echo $, that is 761. And if I'm right here running another shell, now I changed my inside the C shell, I did another subshell called 761, and then now I'm on third shell. I mean, the first one was bash, the second was C shell, then the third one was bash. Now if I just say echo $, and this time is my process ID changed to this. So every environment here I have on this system, everything on those environments, the variables that I do, like if I say export T is equal test, like just say this one echo $T, and then export X is equal 1, and then echo $X. So now it's there. It's only defined within this shell because I invoked this shell to be part of this subshell of this C shell. Similar that if I'm just running an xterm session here, if I'm doing an xterm session here, now the xterm session happens, but then I did it with ampersand, meaning that they run it in the background. So if I do echo $, my process ID for the xterm is right here. So the xterm right here, this is 804. And then if I just look at that one, I can type in exit and that will go away. Or I could just click on this one and it will go away. Or I can say kill -9, 804. And that 804 killed it. So now the session is not there. Earlier, when I told you that the thing is gone, because all of a sudden my parent process ID disappeared. That session that I was there, that one was not active, it was disconnected. So in order for me to just keep that session alive next time, I could do something like, for example, clear the screen. I did this PS, And now notice that echo $x is defined here and echo $t as defined. But if I just type in exit here, now I'm on another shell, which is the C shell, 761. This one is no longer there. The PS with process ID 761, I exit out of that one. So now if I just say $T, it's not there. $X is not there. I can define other things in this environment in Symantic. So I'm going to exit out of this, and now I have only my previous batch. If I just exit out of this one, this whole window disappear on me. Look, the whole this get disconnected. Now I have no control over this, and it just says this one is disconnected. That's what happened last time. So in order to prevent that one, what you want to do is just open this terminal, and then at this terminal, notice that you go to programs, you go to C++, and then now I have the file myxterm.sh. If I just have no invoking any bash on top of this, like here, my xterm is just not even having anything on the top saying what kind of program it is. So I'm gonna just do a couple of things here. My term, and right here on the first line, I'm gonna go and say, okay, I don't need these extra things. I'm just gonna get rid of them. And I'm gonna put one line, shebang, they call it, /bin/bash. And this is just telling me that I'm going to use the bash the script. And then if I want to put a comment on the Unix shell scripting is pound rather than 2 forward slashes. I say, and this script will run for xterm window. Please use no hub to prevent closing on you. So this is just like something you can even make this part as an echo to the user. So this, when the user comes in and they see it, and then you could do this one, echo -e for giving the terminal, and then new line characters here. New line characters on this is also the same here. So now if I run it, it's going to run, but I still did not prevent it from hanging. So rather than running it like my xterm.sh, this time I'm going to say run the